Hi, welcome back to Everyday Race. Today I'm setting up my my ECU. I'm setting up a strategy that I'm gonna tune my ECU to work with my turbocharged engine. So here on the screen you can see um, I've set up two maps for my fuel and two maps for my ignition timing maps. Basically, uh, I have the primary load, which is going to be alpha N, just like a factory OEM ECU did. Basically what it looks at the TPS percentage and the RPM, and that's how it figures out how much fuel to spray in the engine. But since I have a turbocharger on the bike, it's actually going to pressurize the intake manifold, so it's going to add a lot more air in the engine, so I have to add more fuel to have correct airfill mixture. And since the turbocharger can spool up at any time, there's going to be some lag. For example, if I get on it at 5,000 RPM, it's not going to spool up till about 7,000 8,000 RPM. But if I get on it at 10,000 RPM, it's not going to spool up to like 10,500 RPM. So I can't run just an alpha N map alone. As you can see here, for the ignition, I'm going to do the same thing. I'm going to run a primary ignition load as an alpha N, and secondary ignition load is going to be speed density. So it's going to be the same way. This is going to be this is a factory ignition timing map for the bike, and as the boost comes on, it's going to either add or subtract the ignition timing. So for example, let's see, at 12,000 RPM, as you can see, at 100% TPS, my ignition timing is at around 35.5 degrees before top dead center. But if I add 15 pounds of boost on this map, we're going to look at 200, we'll look at 190 kPa. As you can tell, at 12,000 RPM and 190 at 12,000 RPM and 190 kPa, we're seeing -6. So what that means is that the total timing is going to be 29.5 degrees before top dead center. It's going to be 35.5 degrees on the primary map minus 6 degrees on the secondary map. So, but for me to be able to do all that, I have to tune either one or the other map first. So the plan is to tune the engine without any boost first, and find volumetric efficiency of the engine with no boost. And after I have this map, I'll be able to start tuning my secondary maps for both boost for fuel and ignition timing right here. So these are just example maps that I'm gonna have to modify once I get done tuning. So for that, I could either remove the turbocharger from the bike and start tuning the fuel map, or option number 2 is I have to find a way to bypass all the exhaust going into turbocharger. So for that, I'm going to remove a spring in my wastegate. Since there's not going to be any there's not going to be a spring in the wastegate. The wastegate's going to be open, and all the exhaust is going to bypass the turbo. So let me go ahead and remove the spring. So this is the external wastegate that I'm running on my bike. So what I'm planning on doing is I'm going to remove these bolts, and I'm going to remove the spring. That way the wastegate stays open, and I'll be able to tune my alpha N fuel and ignition map. So I'm going to use a 4mm Allen wrench. Going to remove them real quick, and we'll see what's inside. Alright, so I've removed the hat from the external wastegate. As you can see, there's a spring, and there's a seal around the piston. That's what opens up and closes and lets the exhaust bypass the turbocharger, which is right here. So I'm going to go ahead and inspect the seal. It looks pretty good. I have yet to have it apart. And next I'm going to go ahead and put the hat back on without the spring. That way I can tune my naturally aspirated map. And then after I get done doing that, I'll install the spring, and I'll start tuning my boosted map. So let me go ahead and put the sucker back in. Alright, so I'm just tightening up the last bolt, and now she'll be ready to get tuned, naturally aspirated, and we'll go from there.